Hello, everybody. We are going to continue our notes on section 7.3 with rational expressions. And tonight we're going to talk about multiplying and dividing. So remember we said that rational expressions are basically polynomials that are in fraction form. They follow all the exact same rules that regular fractions follow. So if we're talking about multiplying regular fractions, such as these, do we need a common denominator? No. So what would I do? Well, when we multiply fractions, we multiply straight across. But can we simplify this before we do that? And the answer is yes. We look to cross reduce. We're not cross multiplying, we're cross reducing. So do 7 and 10 have anything in common? No. Do 3 and 12 have anything in common? Yes, they both can be reduced by 3. So I'm going to do that before I multiply across, and now I've got 7 times 1 on the top, or the numerator, and 4 times 10 on the bottom, or the denominator, and so my fractional answer is 7 over 40, and that's already in simplified form. We can do that exact same thing with our rational expressions. We do not have to have common denominators, remember, in order to multiply. So the only difference between what we just did and what we have here is we get to factor. So we'll start with factoring. That's our very first step. Factor everything you can. Minus 9 is a difference of squares. So it's going to be x plus 3 times x minus 3. On the bottom, that x squared, well, there's nothing to factor because I don't have any adding or subtracting there, but I could write x squared as x times x if I wanted to. All right, on the top right, x squared minus 3x. That has a common factor of x, and we're left with x minus 3. There's no other factoring we can do from that one. Then on the bottom right, there's no common factor, so we need the factors of negative, which will be positive 4 and negative 3. Perfect, so we've done all of our factoring. Next, restrictions. So remember, you cannot do any simplifying until every x in the denominator has a restriction. So we have this x equal to 0, this x equal to 0, x plus 4 cannot be negative 4, and x minus 3 cannot be 3. Technically, we don't have to repeat those two, but just to get in the habit of making sure you check for every single x that's in the denominator, it's okay if you write it twice. Now that we have done our factoring and our restrictions, we can reduce or simplify. So I'm going to come through here, and any top with any bottom that is exactly the same can get crossed off. So we have these x minus 3's, and I have these x's. And that's it. So we can write what's left. On the top, if I look at the whole top, I'm left with an x plus 3 and an x minus 3. On the bottom, we have an x and an x plus 4. Now, if you want to, you can multiply all this back out, but we don't need to do that. We can leave that right like this, as our final answer, noting our restrictions at 0, -4, and 3.